Alright, here's my video for lesson 522, and the focus today is on Pythagorean triples. Okay, here's my intro to this lesson, and it's really dealing with what have we covered already. And in lessons 5.1, anything in that 5.1 portion of this chapter, we were talking about sine, cosine, and tangent. And remember, basic sine, basic cosine, basic tangent, your basic trigonometry is used to find the missing side of a right triangle. Okay? Usually in those cases, or anytime in those cases, it's a right triangle, so it's a 90-degree angle. They give you one other angle, and they give you one side. And then you use sine, cosine, or tangent to find one of the missing sides or both missing sides. Okay? Additionally, in 5.1, we also learned about inverse sine, inverse cosine, and inverse tangent. Inverse sine, inverse cosine, inverse tangent, those inverse trig functions we use to solve for missing angles of a right triangle. And generally, what those will look like is it'll be a right triangle, so it'll have a 90-degree angle in it, and then you're going to have two side lengths. And you're going to use those two side lengths and your inverse trigonometry to solve for a missing angle. Okay? Now, this doesn't really get covered in this lesson here, so if you have questions on trigonometry or inverse trigonometry, make sure you reach out over the course of the next week or before Chapter 5 is over to get some additional help on that. What we're going to see here in today's lesson in 522 is going to be review 521. In 521, that was our 30, 60, 90, and 45, 45, 90 rules. And we're going to learn this new rule, which is the Pythagorean triples. Okay? So let's start taking a look at them. Here we have A as an example of our 30, 60, 90, because this is 30, this is 60, this is 90. All right, and so if I call this side Y, and I call this side down here X, I can start solving. The big thing to remember here is across from your 30. Across from the 30 is your short leg. Across from your 60 is your long leg. And across from your 90 is your hypotenuse. So X is short leg, Y is long leg, 12 is the hypotenuse. Remember, this is pretty much the pattern to a 30, 60, 90 is short leg times 2 is hypotenuse. Short leg times the square root of 3 is long leg. And so the only x value that would work here is x equaling 6, because 6 times 2 gives you 12. It's the only number that would work with. All right, same kind of thing. Now that you know x is 6, well then 6 times the square root of 3 is going to give you y. And so your y would equal 6 times the square root of 3. And you have your answers for those missing sides. Here in B, we have an example of a 45, 45, 90 triangle. And I know it's 45, 45, 90 because it's isosceles right. And let's remember what those two words mean. Isosceles means that they have two congruent sides, a triangle with two congruent sides. And right means it has a 90-degree angle. Since it has both two congruent sides and a 90-degree angle, it's isosceles right. And isosceles right triangles are always 45, 45, 90. Okay, 45, 45, 90, the two legs are the same. It shows that here with these tick marks, but the two legs are always the same. And then to find the hypotenuse, it's just one of the legs multiplied by the square root of 2. So my hypotenuse here is 3 times the square root of 2. And I have that one completed. So anytime 45, 45, 90, the two legs are the same, choose one of the legs, multiply it by the square root of 2, you'll have your hypotenuse. Here, we have a Pythagorean theorem problem. All right, and remember, we haven't seen this in a while. Pythagorean theorem we use when we don't have any angles other than our 90. So we don't have an angle up here, we don't have an angle down here. All we have is our 90, and we have two sides. So just a 90 and two sides, we use the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. A and b are your legs, c is your hypotenuse. And so my legs in this case, that is 3 squared plus 4 squared equals c squared. And you go on to solve. Well, if you go on to solve, you end up with 9, because 3 times 3 is 9, plus 16, because 4 times 4 is 16. Well, that equals 25. You have to square root 25, because c squared equals 25. And I don't want c squared, I just want c. So I got to square root both sides, which ends up telling me c equals 5. And here is the first experience with what is called a Pythagorean triple. My definition of a Pythagorean triple is when you can use the Pythagorean theorem and come out with 3 whole numbers. All right, so a right triangle with 3 whole numbers is a Pythagorean triple. Keeping going here, we have another 30, 60, 90, same kind of thing. This is going to be my short leg. It's across from my 30. It's the short leg, which means the hypotenuse is going to be 20 because short leg times 2. And then that means this side here is going to be 10 times the square root of 3 because short leg times the square root of 3 here. All right. More importantly here, we have another Pythagorean theorem problem. And to save some time in the video, I'm going to tell you that this answer here is 10. Now you can check with the Pythagorean theorem, a squared plus b squared equals c squared, to show that that really is going to be 10. You would end up with 36 plus 64. 36 plus 64, that's 100. The square root of 100 is 10. Now what I want to point out here in my video is that this right here is just a variation. D is just a variation of C. C is 3, 4, 5, that Pythagorean triple. Well, this is the same Pythagorean triple, it's just varied. Because 3 times 2, well, that's 6. 4 times 2, well, that's 8. And 5 times 2, that's 10. So it's the 3, 4, 5 Pythagorean triple, it's just a variation of that. Okay? And so what we're going to see here in today's lesson, and the big idea of today's lesson, is you're going to have two Pythagorean triples. You're going to have 3, 4, 5, and 5, 12, 13. We'll see that down here. All right? And then everything we do in this class is just a variation of those two Pythagorean triples. Okay? So here, I said this. We have the other one. It's going to be 5, 12, 13. That's the other Pythagorean triple. And we clarify that here in this slide. Okay? So the two they say here are 3, 4, 5, 5, 12, 13. All right? And then we have variations of those. And so I want to show that here. Let's look at some variations of the 3, 4, 5 triple. These are the ones you need to memorize, by the way. 3, 4, 5, 5, 12, 13. If you memorize those, you'll be good in this class. All right? Some variations of this could be 6, 8, 10. We saw that one. That's just all of them multiplied by 2. Another variation of this one could be 9, 12, 15. Another variation of this one could be 15, 20, and 25. Okay? They're all 3, 4, 5 Pythagorean triples, just varied in different ways. This one here is multiplying by 2. This one here is multiplying by 3. This one here is multiplying by 5. Variations of 5, 12, 13. Well, same kind of thing. We could have one that would be 10, 24, and 26. That's all multiplying by 2. You could have a variation being 15, 36, 39. You could even have one being 2.5, 6, and 6.5. Okay? This one is multiplied by 2, this one's multiplied by 3, this one's multiplied by 1/2. Still a variation, even if I multiply it by 1/2. Okay? And so to keep an eye out, and I'm not going to go over many more in this because I'm already at 8 minutes, and just to see me do more examples isn't going to help. You got to work through 5, 6, and 7 here. In 5 and 6, you have to just solve for your missing sides. I mean, in all of them, you need to solve for your missing sides, but use your shortcuts to do so. In A, use your 30, 60, 90 relationship. In B, use Pythagorean theorem or Pythagorean triples. In C, use your 45, 45, 90 relationship. Okay? Look in this one. All right? You'll end up solving for your hypotenuse, which you could call C. Make sure you look for which, if you use Pythagorean theorem, that is, make sure you look to see, okay, which Pythagorean triple is that a variation of? Because I promise you that it is a variation of one of ours. Okay? Here we have another Pythagorean triple or Pythagorean theorem. Here you have another 30, 60, 90. And then you get to 7. And 7 is kind of difficult. But 7, we can find the area and the perimeter. And the best way to do that is to see this as two different shapes, as a composite shape. Okay? We can see it as a triangle there and a triangle here. In this one, we know that this is 6. These are all 6 because they all have that dashed line through them, meaning they're all 6 here. Here, we know that using my 45, 45, 90 rule, that this would be 6 and that this would be 6. And that means this is 6, and that we have all 6s here as well. Interesting. So you can find your area and perimeter, or you can find your perimeter of both doing that. Area is a little more difficult. Okay? Area of B is not too bad. Remember, a triangle is 1/2 base times height, and a square is just base times height. So you can do that here. You have a base, you have a base, you have a height, and here you have a base and you have a height. So you can find it there. For this one, it's a little tougher. You can find the area of this box down here because you have a base and a height. And so you can find the rectangle or the square area. Triangle up here is a little tougher. What you need to do is you need to split this into 2 right triangles. Okay? When you split this into 2 right triangles, what you get is your 60-degree angle gets split in half. So you get one angle here that's 30, and you get another angle over here that's 30 as well. Well, when you split it, you also get 2 right triangles down here, and you actually get 2 30, 60, 90 triangles. How convenient. Well, you can use that 30, 60, 90 relationship to figure out, okay, if this is 6, that means this must be 3. Same for over here. This must be 3. And the height must be 3 times the square root of 3. Now, there's different ways to do this, but you can find the area of both right triangles and the area of your rectangle down here and add it all together. Or you could find the area of just this big triangle up top and the rectangle down here and add it together, and you should get the same answer. You found the same area. All right? It's challenging, but what that problem does for us is it shows us that these 30, 60, 90s can kind of save us time on longer or bigger problems. All right? My video went a little long here. I hope you find it helpful. If you have questions, like I said in the beginning of the video, make sure you reach out and ask for help over the course of this week. And I would be more than happy to explain old concepts or this concept further.